Hello, everyone. Welcome to this online event of the Materials and Embodied Carbon Leaders Alliance, MECLA. Today, we'll shine the light on the MECLA Spotlight on ways forward with trees. Our speakers will take us through some of the challenges when choosing timber. They'll ask difficult questions and they'll set out their recommended way forward, the way forward with trees. My name is Hudson Worsley from Precinct, and I have the pleasure of being the chair of MECLA and the host of today's event. I'm joining you today from Gadigal land of the Eora Nation, and I would like to acknowledge that we are all on Indigenous land. I pay my respect to elders past and present, and welcome any Aboriginal and Torres Strait Islander people joining us today. Welcome, everyone. Some quick mechanics on today's session. We are recording the event. That's already started. We have over 350 registered attendees, so welcome to you all. Please use the chat function for your comments and the Q&A function for your questions. I'll do my best to field questions for the panel, and the speakers will no doubt respond to comments or questions as well, and probably people in the audience. We have a real ecosystem of expertise joining us today. As always, I would like to remind all MECLA members and attendees of MECLA's governance requirements. As you know, MECLA operates in a pre-competition environment. We do not tolerate any anti-competitive behaviour, and this is really important to the ongoing success of MECLA. If you are aware of a conflict of interest, please speak up and we may adjust accordingly. Okay, so let's set the scene. We are in a climate emergency. Recent science publications and communications just in the last week have reinforced the nature of the urgency of the situation, and we are midway through the critical decade for action to get us onto a trajectory of emission reductions needed to achieve net zero by 2050. To get there, we need deep drawdown of atmospheric carbon, and you guessed it, we'll be relying substantially on healthy forests to achieve this. In a presentation to MECLA last October, architect Paul Ha, who will be speaking shortly, suggested that we need to look more critically at the increasingly popular perception amongst design professionals and the public that wood is the ultimate building material. This view is based on the assumption that a timber product stores more carbon than it is giving off during its harvesting and processing. Paul encourages us to look at the forest from which the wood is taken, and to consider the emissions in the forest when trees are harvested. These emissions dwarf the carbon stored in the timber procured, and Paul argued that they represent a forest carbon debt, a term we'll hear unpacked today. And that debt should be repaid by healthy forest regrowth over time, as is assumed by EPDs, Environmental Product Declarations. But with climate change, that's making this harder by exacerbating the incidence and severity of bushfires, heat and drought-related stresses. Post-harvest regrowth and the return of carbon to the forest is at risk, and certainly at risk within the timeframes needed for impactful climate action. So how do we manage naturally regenerating and purposefully planted forests, and with a proportion of the forest biomass that can be held in long-lived carbon sinks like timber in construction or biochar for agricultural soil improvement? Paul and others ask whether EPDs address the carbon dynamic that occurs in the forest. And of course, alongside the entwined with forest carbon debt, there are concerns around biodiversity and broader forest health. So this afternoon, we're bringing together 5 experts across several disciplines to look at the initiatives in forestry, timber and construction industries that show great promise in limiting forest carbon debt and building resilience for natural and planted forest ecosystems in our changing climate. Together, our speakers will help us explore the way forward with trees. Our first speaker will be Patrick Baker, a professor of silviculture and forest ecology at the University of Melbourne. His work focuses on understanding how forests change, the forces that shape these changes, and how this knowledge can be applied to better manage forests in a changing world. Patrick has degrees from Yale University, the University of Washington, and a CV of international experience too long to read right now. After Patrick, we'll hear from Mark Wooten AO. Mark is a geographer by training and a farmer by practice. He's a deputy chair of Victorian Agricultural Climate Change Council. He's been the chair and was a founder of the Climate Institute. And with his wife, Eve, he strives to produce carbon neutral beef, lamb, wool, and timber at Jigsaw Farms near Hamilton in southwest Victoria. Now, Jigsaw Farms is a 3,500 hectare operation, runs 18,000 merino ewes, 820 head of cattle. Since 1996, the family has also planted 18% of the land to trees, half high-value saw logs, the other half for biodiversity plantings and waterway restoration. Then we'll hear from Daniel Wright. He's the Director and National Business Development Manager at Australian Sustainable Hardwoods, which grows plantation eucalyptus for manufacture of high-value, long-lived products. Darren Minto will then talk to us. He's the client relationship manager at Crafted Hardwoods, and he'll introduce us what his business is doing, how they do it, and some of the challenges in the Australian market and where they need support. Both Daniel and Darren bringing suppliers' perspectives to this conversation. And finally, we'll hear from Paul Ha, an architect of 46 years standing. Paul has developed a keen interest and expertise in trees, wood, and timber design. In the context of our climate and nature crisis, he regards timber as amongst the best or the worst building materials in use in construction, depending very much on where and how it's sourced. This has motivated him to frame and administer an eco-housing project, established a not-for-profit aggregation network, design and construct many buildings, and broadly share his knowledge around environmental and socially responsible timber products. Paul's been recognised with 10 Australian Timber Design Awards and the 2020 Australian Sustainability Award for Lifetime Achievement. So this is an impressive lineup. Let's get on with it. Paul Baker, can I please hand over to you to get us started? Sorry, Patrick.
No, that's okay.
Yep, you're there. Great. I'll hand over to you. I'll try and get your name right next time. Apologies.
Thanks, Hudson. It's a pleasure to be here this afternoon. I'd first like to thank MECLA for organizing this event and inviting me to participate. I'd also like to acknowledge the traditional owners of the lands on which I live here in Geelong, the Wadawurrung, and pay my respects to their elders, past and present. Today, I'm going to talk about the future of Australia's temperate forests in a changing world and why I think forest management should be part of that future. Second. So I'm going to start with two general points for context. The first is that we all value forests. We value them for the biodiversity that they support, the carbon they sequester, the wood and the wood products that they produce, and the clean water that flows out of them, amongst other things. The second point is that around the world, forests are getting hammered by climate change. So either directly due to warmer, drier conditions, as in these jarrah forests of southwest WA that are experiencing quite severe dieback earlier this year, or indirectly through more frequent and more intense fires, as you can see in this photograph from a helicopter over East Gippsland after the Black Summer fires of 2019-2020. Some of the impacts of climate change may be more subtle and slow-moving. So this is a map of the areas within about 250,000 hectares of the Central Highlands of Victoria that are suitable for Eucalyptus regnans, what we in Victoria call mountain ash, suitable for their seeds to germinate and grow under the current climatic conditions. So the green is where the seedlings can germinate and grow. This is the expected area suitable for mountain ash regeneration in 2080, using middle-of-the-road assumptions about climate change. And so you can see it's a massive contraction of the potential areas where this species can regenerate. So over most of its current range in the Central Highlands, the tallest flowering plant in the world, which often gets up to about 80 meters tall, won't be able to germinate and grow into a 1 meter tall seedling by the end of this century. And this has grave implications both for carbon storage and for habitat and biodiversity. So with that as context, I want to start my talk at the end, I suppose, by giving you the key take-home message first. And that is that forest management can help make forests more resilient to the direct and indirect impacts of climate change. However, it's important to acknowledge that not all forests are the same, and not all forests are going to respond in the same way. So, as an obvious example, native forests and plantations are very different in composition and in structure. And native forests themselves, there's many different types of native forests. And within any given native forest type, be it river red gum or silvertop ash in the east or karri in the west, there may be quite a lot of variability in structure and composition. So the question that we really need to ask is, which forests can management most help to make more resilient? And I think that there are two obvious kinds of forest. The first is dense regrowth, which you see in this picture here. So dense regeneration establishes after a severe disturbance such as fire or flooding or clear fell logging, and it can lead to crowded stands in which each tree has access to very few resources. So the resources in the stand are divided up amongst many trees. These trees are vulnerable to drought and fire. They're vulnerable to pests and diseases, and they're either growing very slowly or not at all. So they aren't sequestering carbon and they're not producing wood. And so, and in addition to which, they don't offer much in the way of habitat value either. The other type of forest that might benefit from forest management is one that has been severely impacted by climate-related disturbances, particularly bushfires. Here, the focus really needs to be on restoration. How do we get forests returning back to the more typical functioning? But particularly in the context of climate change, it's important to ask, how can we adapt them to the more challenging future conditions that they're going to face? Now, given the time I have to talk here today, I'm just going to focus on the first type, dense regrowth forests, and talk about how forest management can help make them more resilient to climate change. So, what exactly can forest managers do in dense regrowth stands like this one here in Western Victoria to make them more resilient to climate change? The short answer is, where we have very dense stands, we can reduce the number of trees. Now, this has multiple benefits. The trees that are retained have more resources to grow. That means that they'll be more vigorous. That means they'll grow faster. It means they'll get bigger sooner. And that means that the period during which they're vulnerable to being killed by fire and drought is shorter because they get bigger quicker. And this isn't news, right? We know this from studies all around the world that if you reduce stand density, it increases resilience to climate change. This is well established. I'm going to just give you one example from Australia just to illustrate this in a local context. And specifically, I want to focus on how forests with fewer trees, so lower density forests, are less vulnerable to an intense drought. So these pictures show two plots from a spacing experiment that was established by the Victorian Forestry Commission in the late 1960s. On the left, they planted 8,000 trees per hectare of river red gum. So this is up along the Murray River. And on the right, they planted 600 trees per hectare. These two photographs were taken at the same time in 2007, so when the stand was about 40 years old. So 8,000 trees per hectare on the left means that each tree had about 1.25 square meters of space to grow in. And 600 trees per hectare on the right means that each tree had about 16 square meters to grow in. So you'll notice that in the denser stand on the left, there's lots of small trees and there's a lot of dead trees on the ground. In contrast, in the low density stand on the right, the trees are much bigger and there's very little evidence of mortality. There's just that one large tree that's fallen down through the middle. So what's really interesting with this forest was what happened when it experienced an intense drought. So many of you may remember the Millennium Drought, which impacted southeastern Australia from the late 1990s to about 2010. In the dense stand on the left, the Millennium Drought led to a 500% increase in mortality, right? And so in the inset graph there, the pink column is the period of the Millennium Drought. And you can see how the mortality has increased quite dramatically. The stand basically collapsed. In contrast, the low density stand on the right, and this is consistent again with studies all around the world, showed no effect. There was no change in mortality. Basically, this stand skated through the Millennium Drought effectively unaffected. Now, given that drought events similar to the Millennium Drought are forecast to become more common in the future, this is a real worry. But it's only a worry if your stands are super dense. Another point that's worth making is that we know that big trees are more resistant to fire, right? So we want to have more big trees in our forests. So the figure here illustrates the relationship between the size of a tree and the probability of mortality. I'm using some work we did here. This is Eucalyptus radiata as an example. So the y-axis is the probability of mortality. So 1 being all of the trees are killed, 0 being none of the trees are killed. And the x-axis is the diameter at breast height. So that's 1.3 meters off the ground. We put a tape around the tree and we measure how many centimeters it is in diameter. The different colors of the lines represent different fire intensities. The red one is a very high intensity fire. The pale yellow one is a low intensity fire. In all cases, the probability of mortality decreases as the trees get larger. So what does this mean in terms of how forest management might mitigate fire impacts? So this is an example from a thinning trial of mountain ash in Victoria. So the unthinned stand is on the left and the thin stand is on the right. Same species, same site, same age. There's two things to notice. First, in the thin plot on the right, there are fewer trees, which is what you would expect because it was thinned. Second, the trees in the thin plot are much larger. So the x-axis is the stem diameter, the diameter of breast height again. The red vertical line is at 100 centimeters in diameter. And we put that there because that's the diameter at which trees begin to form hollows for animals like greater gliders and leadbeater's possum. In the thin stand, almost all of the trees are greater than 100 centimeters in diameter. In the unthin stand on the left, there's only one tree that's bigger than 100 centimeters in diameter. And again, these trees are all the same age. If we simulate a moderate intensity fire in these forests, over half of the trees die in the unthinned plot. That's because, as I said, they're smaller and therefore they're more vulnerable to fire-induced mortality. But in the thinned plot, only 4 of the trees died. Again, same forest, same species, same site, same age, same everything. The only difference is the plot on the right was thinned and the plot on the left was not. Now, from a carbon point of view, the issue is that all the trees that are killed by the fire are going to begin to collapse, decompose, and release their carbon back into the atmosphere. In the unthinned plot, that's close to 40% of the carbon in the stand. In the thin plot, that's less than 10% of the carbon in the stand. So thinning has effectively fireproofed the carbon in these stands. So what exactly does reducing stand density to produce more resilient stands look like? So I'm going to show you a sequence of slides from a pilot project that was conducted in lowland mixed species forests in eastern Victoria. And here the goal was to retain forest cover and focus the growth on the best trees in the stand. Now, it's worth noting that this wasn't a formal research project. This was just a local sawmill owner and a logging contractor who felt that there was an opportunity to try forest management that was less intensive than what was happening in the broader landscape. And so they wanted to see if they could do something a little bit different. So the first slide here is the pre-harvest view. Okay, so I'll show you a sequence of slides. So this is just before they were harvested. And this is 2 months after the harvest. So obviously what you'll notice, there's still a lot of trees that are standing here. There's a fair bit more space amongst the trees so that you've effectively reduced the density and spaced the trees out. And you'll notice that there's some logging debris on the ground. 3 years post-harvest, and the thing for me as a forester to note is that the crowns of the trees are deep and they're very green. And what that indicates that these trees are very vigorous, that they're growing well. You'll also notice that the logging debris on the ground has largely disappeared. Now, what is a sort of interesting side note to this is 4 years after the harvest in 2017, a wildfire burnt through this landscape. But instead of completely consuming the forest canopy, as it did in many of the surrounding areas of forest, the fire dropped to the ground and burnt through the understory. So you'll notice there's some charring, the black base of the trees, and some of the leaves, particularly in the lower part of the forest, are scorched or burnt. But there's very little evidence of mortality amongst the trees. None of the full crowns were scorched. Most of the trees have pulled through this fire. So that's a good outcome for carbon. That's a good outcome for timber, and that's a good outcome for habitat. Now, one of the major constraints to this type of forest management, where you're removing small trees to effectively give more resources to the trees you retain, is the need to cover the costs of the operation, right? So if you remove the small trees, historically, they've been considered to have little or no value. And so it makes it difficult to undertake these operations at large scales. However, recent advances in engineered wood products, EWPs, might fundamentally change this. So if you can take small pieces of wood from the small trees that you take out of the forest, and you can join and glue them together, they can form much higher value wood products such as glulam, laminated veneer lumber, or LVL. And some of those you see in this picture taken from a new building that's just been recently built in at Murdoch University in WA. This could be used to cover the costs. These higher value products could be used to cover the costs of reducing the stand density and overstocked stands over large areas. This is a potentially transformational opportunity to use forest management to remove small trees, capture their carbon in high-value engineered wood products, and at the same time make the forest more resilient to climate change. In effect, linking forest management, wood processing, and the built environment to make forests more resilient to climate change. So Daniel and Darren, who are going to talk after me, are surely going to be showing you some of the amazing things that Australian wood processing companies are doing in this engineered wood product space. And it really is remarkable and I think transformational in many regards. So I'll finish here and I'll just reiterate my take-home message, and that is that forest management can make forests more resilient to climate change. Which forest would most benefit from this is an important discussion that we need to have. But given current trends in the climate and the changes that we expect in the coming century, making forests more resilient to climate change would be a good thing. And I'll stop there.
Thank you, Patrick. That was a real eye-opener for a non-timber, non-forestry person. I was, wow, taking notes, and really look forward to having you on the panel at the end of our session. Thanks very much for that. Now, Mark Wooten, can I ask you to turn your camera on? G'day, welcome.
Good afternoon.
Thank you for joining us. I'll hand over to you.
So I also wish to acknowledge the traditional owners of where I live, which is the Gundtjmara people in southwest Victoria. But I also am going to steal as a segue from the previous speaker in terms of what he did. And I'm going to say forests can make farms more resilient to climate change, not necessarily management. So what we're going to do today is I'm just going to run through pretty briefly here and try to keep the time, which I'm setting my clock on, explaining what we do here at Jigsaw Farms and why we do it, and then touch on some of the issues with what we're doing in the agroforestry and some of the things which we've hit a bit of a wall on. It's going to be a bit of a burst for the 10 minutes, so I'll just flag for people who want to follow up. There are 2 papers that are attached on the MECLA website, which explain in full what's gone on with our 2 carbon studies here and the forestry side of the carbon study, which was done by Hugh Stewart and Rod Keenan from Melbourne Union. So if you want to go into the details, it'll be sitting there. Next slide, please. So this is where we are. We're down just north of Hamilton. That's the Grampians in the background. For background, it was touched on before, we're 3,500 hectares with mixed soils, mainly basalt country. We've got, it's pretty undulating to flat. We've got 2 significant creeks going through. If we're selling the property, we say there's 650 mils of rainfall here. If we're actually being honest in what we're getting, we're sitting between 570 and 590, and it looks like it's drying as we're getting perhaps a more significant shift going on with the climate. We're winter and spring dominant rainfall, and we've got 800 breeding cows and 18,000 sheep, which are right smack in the middle of their calving and lambing now. And we had the worst wind we've had here for a long, long time, and I think other people in Victoria might be getting it now on the east of the state. And we've had our survival rate last 24 hours to do with the trees and the shelter has been astonishing, to do with what the trees have provided in terms of shelter belts. So that's just an active one. Next slide, please. We're a profitable business. Last 2 years have been tough, but other than that, we've had a pretty good, healthy business, and we do that by being a high input, high output system. We've doubled our food and fibre since we've taken over the properties in 1996 from what was run previously there. So it's a high input system. We use fertiliser, and we try to do it at best practice as we can. We reached carbon neutrality between 2009 and 2014, which I'll touch on later. We're actually slipping out of carbon neutrality now as our trees are reaching maturation. One of the key things is our biodiversity indicators, which the trees and the creek protection give us. We've gone from 48 bird species in 1996 to now sitting at, it's actually 176 as of the weekend. And in broad numbers, we've got half production trees and half biodiversity, permanent revegetation plantations, and a bit over 600 hectares of those going forward, which make up about 18% of the property. Next slide, please. What I'm going to show you here is 3 old slides, so you'll have to deal with me. If you're looking in this is at the one. These 3 slides are from the one location. Slide was taken in the 1960s. You'll note that there's ringbark red gums. We lived in a scheme where a country where you're encouraged to, in fact, it was to actually be allowed to graze, you had to ringbark the trees as part of the allocation going back. And they sit as skeletons. They're still there, most of them, interestingly enough, providing amazing bird hollows and things. And then in the middle, you'll see that dried out creek, which is all salted. And in general, you'll see the landscape is, even the green parts, it's nutrient depleted onion grass. Then we move to the next slide, please. That's the same location in 1996, and there's young plantations coming through there. You'll also note that there's some clump plantations where there's been little salt burns, and you can also see that there's a dam being put in, and there's been through the trees in the recharge area being in place, we've had a quality improvement in terms of the actual salting in that area. So there's been a lot of land work and some erosion control going on. So these are the co-benefits which I talk about of the trees going forward. And in the next slide, which is the same location, you'll see that there's been a thickening. We've introduced some more agroforestry species, predominantly MECLA spotted gums, but we've also got portuoides, southern mahoganies, and some tricarpo, and some salignas, which are in the salter areas, seem to do all right there. So we've got a fair range, but predominantly with spotted gums. Our soil carbon now has reached capacity at 3.5 to 4%, so we get no allowance in that in our carbon studies, which I'll touch on, or you can look at the papers. Our salt's now under control. The biodiversity is booming. We've doubled the stocking rate, and our carbon intensity per unit of production, whether that be wool, beef, or lamb, has dropped dramatically as well. So we're in a very competitive space from that point of view. If you imagine that's our footprint, the carbon side of it, and what the trees are doing is try to offset that, or we use the language inset. If you go to this next slide, please. This is if you came here, there's a creek down the bottom here. You'll see the colour change. That's the smaller shrubs there. They're permanent re-veg and mixed indigenous species. And above that, you've got, in the better soil types, you've got some of those, that's the maculatus, the spotted gums. So that was in 2001, that photo was taken. If you imagine, it's changed dramatically since then. Then if you go to this next slide, this is down at where I am at the moment, which is our home block, which is looking under the Grampians. You've got these co-benefits of these shelter belts. And the best way I can do to describe it is, if your body's got its main arteries, which are the bigger plantations, which are anywhere between 60 to 120, 130 metres across, they're along the creek areas and are there for a particular job to do with salt control or to do with erosion control and they also act as a biosecurity protection. So we fenced out the creek areas. And so those bigger plantations sit there, and then you've got a patchwork of the jigsaw where you have these smaller 27-metre wide smaller plantations which feed in there. And just as an aside, one of the interesting things to come out of the carbon study, which Rod Keenan and Hugh Stewart did, is that our tree growth and obviously therefore our carbon sequestration was increased in these smaller plantations, which is a good story about why farmers are a really good prospect in terms of doing agroforestry and producing saw logs. And interestingly enough, just as a broad statement, but pretty solid statement is that they are also sequestering for the first 25 to 30 years, the agroforestry double the carbon sequestration rates of the permanent revegetation. So there's some really positive things going on. And then you get into these other things which are going on is that the trees are actually provide us if there is fire risk by having them spread out, they're a lot less risky than having them in big block plantations, and they also improve our lambing percentages. We've gone from 70-odd% in lambing percentages 20 years ago to sitting about 120% in the merino operation, which if anyone knows merinos, they're looking for a reason to die at this time of year. So it's a really positive place to be. Then the next one, please. The other one is this is looking at our carbon study. I won't get lost on this, and this is in that study, the Richard Eckard paper, which is one of the papers attached. In a nutshell, methane's our big baby, and we've got a problem there. So in broad speak, we've got 7,000 to 8,000 CO2e tonnes being produced by the farm operation, and we have to offset them by the trees. Next slide, please. So this is a beef emission. So just to show you we're not lazy farmers, we're actually well below what is normal practice. In terms of what's produced on farm. If you're in Northern Australia, they're normally at the higher end, and in Southern Australia, you're at the lower end. And that's all about fecundatory, so how many units of either lambs or calves you have per maternal unit. And it's also based on your genetics and your feed efficiency. So we're in a good space there. With the trees, if you allow for sequestration, we're getting right down, and we compete with chicken and other really low carbon products with the red meat industry, which is really interesting when you consider that most of the people we supply products to have signed up to the SBTI's, the Science Based Target Initiative, and they're looking down to buy product from people like ourselves, whether it be food or fibre, beef, lamb, or wool, that are going to lower their profile because they have to somehow offset it elsewhere. We sell product to Coles carbon neutral beef, and we also sell wool through New Zealand, through ZQ to the high value North American and European sports wool products like Icebreaker and those things. Second last slide, please. So this is in the tree. I won't get lost on this, but in a nutshell, this is one of the problems we've got in the industry at the moment, where if you go through a standard full cam analysis of what the trees are meant to be done on a modelling basis, our trees outperform that. And that's what Rod and Hugh did. They did an on-ground and massive study on ground to see what was actually being sequestered on farm. And we found that we were actually sequestering a lot more than the modelling say. And in broad numbers, it's about anywhere up to 4 times more than what modelling says. For our purposes, we did a doubling to do a projection. And the problem is, regardless of that, you'll see the trend line as the trees reach maturation, we've got a problem. So that's where the farm's focusing now on attacking it at source, which is methane, and lowering our footprint through genetics or through food additives. And then the last one, a whirl of knots. This is, if you came here, this is a current slide. If you see that dam, which is a creek above it, there's permanent re-veg around the border, and then above that, you've got your spotted gums. Our issue now is that, and it's touched on the previous presentation exactly, we've started with 1,000 trees per hectare, and we're going to harvest 220. We're going to have a lot of thinnings along the way. We need to do something with these products. So we're looking at great interest with the next 2 presentations on where we can actually use some of these thinnings or some of these to help our other trees become a high value saw log, which in this area is going to be a slow growing, very high value timber going forward. Thank you very much.
Mark, thank you very much. MECLA, we call ourselves a do tank. But I think we've just been put in the shade because there's so much going on your property. That's just remarkable. And so many, I suppose, interrelated co-benefits, really. And the the befores and after photographs really tell the story. So thank you for sharing all of that. Please stay on the line for our discussion at the end. But boy, that was for a city guy, that was a wonderful eye-opener. Thank you very much.
You're very welcome.
Great. Now, Daniel Wright, can I hand over to you, please, mate?
I think so. You've got me there, and I'll share this. Hopefully this one's worked. Hopefully you can see that there. So I too would like to begin by acknowledging the traditional owners. So I come from the Gunai country here. I'd like to pay my respect to elders past and present. And you've introduced me, so I'll jump through this, but I'll start by saying I'm going to take a different approach as a supplier and manufacturer and talk about our product, plantation oak, and some problems, some concerns. It's not as clear as we all think it may be, but also some solutions and some pathways forward. So, quick intro for those who don't know a bit about ash. We're large manufacturers. Yes, we're more than big hardwood timber mills. We're also the largest hardwood manufacturers in Australia, and it's that vertical integration from log through to finished product that gives us the opportunity to compete in international markets. So we do a number of things here at Ash that are Australian only. So we're the only mass timber producer of large volumes of columns and beams for big commercial structures to help the building industry decarbonise with mass timber. We've commissioned the Australia's only pre-finished engineered flooring plant, and there's 13 manufacturing plants that we've got out there in Gippsland. So, of course, all of our sites are third-party audited for environmental and social and other things to verify that we're doing the right thing with our timbers. This here is one of our 13 manufacturing plants. It's looking north on our MassLam lean manufacturing line. That yellow and red box you can see there is one of the largest robotic CNCs. It's got over 160 tools in it. And so we've got some really smart people and technicians. They design buildings in virtual reality, and these robots go and profile those, and then we can deliver them to site and build them off the back of a truck. So we'll talk a bit more about mass timber as a solution in a second. So I thought it would be good for me to start off my topic with a narrative that needs tweaking slightly, and that the industry can transition immediately and there'll be no shortage of wood. I could have found hundreds of these sorts of articles. It's not technically correct. We should definitely be doing more plantation, and I hope to explain one of those pathways today. But a clear transition isn't that black and white. And this should be obvious to most listening, but in case it's not, I'll run through it quickly. Hardwoods, particularly, are used for a range of values. It could be to do with their performance. And you can see here I've colour-coded these just to show some different timber species have different performances, but also a mix of their price and their availability depending on the market. But I've only colour-coded these as an example that they are different. But for example, you can see the walnut column, second last there. Popular timber in Australia. Doesn't look so great because it's colour-coded in the red to oranges there, but it happens to be one of the most expensive timbers on here. Why? Because it's an exceptionally good furniture timber. So just because it's red or green doesn't mean it's good or bad. It just means that there's some differences. It's important to highlight that. Secondly, now when you grow these timbers in plantations, unfortunately, it's not always clear-cut that you'll get the same performance. And so what I wanted to raise here before I get into the good stuff is that those changes in timber performance have an impact on what they're useful for. So here in Victoria, we've closed our native timber industry, largely Victorian ash made up the bulk of that. And Victorian ash is really good structural timber. Now, if we grow that same timber in plantations, it has a number of properties that are different. One of those is structural. And now what we're finding in our tests is a lot of the properties that are published within the Australian standards and within the building codes and so on, this timber doesn't meet it anymore. So now you've got a safety and a compliance issue. Doesn't mean the timber can't be used. It just means it's not that clear cut. Same goes for density. So Victorian ash was a really good timber species in windows, and part of the reason for that was because it met bushfire attack level 19 rating. So that's based on 650 kilograms a cubic metre in density. What we're seeing now is there's a lot of imported plantation timbers coming from different countries, some of them Australian species, but they're being sold as if they still have the same structural and performance and densities, and they don't. So we've got another compliance issue within that side of the industry now, which really needs to be addressed. Now, I could have come up with several of these, but I'm going to get to the good stuff. The other thing is, if you dry these timbers the same as you dry your native regrowth counterparts, they perform differently under drying. And so there's whole timber mills need to understand and relearn how to dry these products, but also then get an understanding of what they're good for. And that's what I'm going to talk about today. So before I get into that, I am conscious not to make too bleak a picture, but I'm doing it for good reason. The point I want to make is, if we're going to use plantation hardwoods, we need to be honest with what they're really good for. In the case of the Victorian hardwood estate, if we were to transition to the plantation that was grown for pulp, about 10% of that is potentially usable for the same timber applications, but the other 90% needs to be engineered. And that doesn't mean we can't do it. And here at Ash, we've worked out ways to do that, and I'm talking about that today. But I think we need to be honest with ourselves about that, because what we're seeing in these couple of slides here is that the investment in the plantation hardwood estate is in decline. And the feedback we're getting from a lot of the growers is because they were promised that the industry would take them, and the industry's not. So I wanted to clear that up first of all. Now I'm going to get into the good stuff. So what is it good for? Now, our plantation oak, which I'm talking about today, is particularly good at helping the construction industry decarbonise by swapping traditional materials for mass timber construction, especially in the MECLA context, where we're talking about embodied carbon. Being a plantation grown estate, it's excellent at decarbonising. So this here is from a trade show we had just recently. This is our MassLam product. We make really large columns and beams and structural flooring systems, which are used for multi-res apartment buildings. They're also used for office towers and so on. We just did a 15-storey office building in Melbourne. And now I'm not going to go into too much detail on each of these, but these are from a slide that I do. I've got a QR code up in the top right for anybody that actually wants to learn about this in more detail. But we've spent millions on understanding this plantation resource, which is largely going to pulp now. And people said we couldn't turn it into good quality timber. We're showing here that we can, but we've had to develop composite products. We've had to verify those. We've had to have them fire tested. We've had to go through the ringer with it. But what we've come up with is a mass timber solution that you can visually express with performance pathways in construction. So part of the smarts on this system is that you can see on the left there, what we're developing is something that's future-proof. These multi-res buildings can be designed as one-bedroom apartments for social housing now, but in 50 years, as clients and occupants' needs change, that could become four-storey, four-bedroom apartments because there's no rigid load-bearing walls. They're intended to be prefabricated and installed extremely quickly. That building on the left, we built 10 stories in 60 days. And that's the cost efficiencies of mass timber. It's not in the material cost, it's in the build speed. And the best thing in the MECLA context, our superstructure is better than carbon neutral. And like I said, we've done all of our tests on this from an acoustic and fire and cost assessing perspective. So what we hope to get to is that as modern methods of construction are adopted more, and we're looking to decarbonise the construction industry further with this sort of innovative idea and material, is that we can start repeating buildings. And when we start repeating, we can get our efficiencies, our cost efficiencies improved, but also the construction industry can start to generate more competitive tenders. And we're on our pathway there, but we've got a little bit more work to do. And yeah, I'd like to challenge that, put that to everyone there to reach out if you're interested in learning more about that. I guess to summarise, I think we've got a huge opportunity as a collective to decarbonise the construction sector using these materials. But if we're serious about using wood that's grown for pulp, I'd like us to stop pretending that we can swap everything over from native to plantation. I think we need to encourage development of products that make sense, and I'd say mass timber is one of those. Thank you.
Danny, thank you very much. Wow, that's a very sophisticated manufacturing setup you've got. Yeah, very impressive. And 13 plants, that's quite the scale. So really appreciate your perspective on that. And yeah, calling out horses for courses, I think. So yeah, really great. Please stay around for our next, hear our next speaker, and then hang around for the panel discussion. So Darren Minto, can I hand over to you, please, if you're there? Oh, beauty. G'day. There you are.
Hello, everyone. Thank you. Thank you to the team at MECLA and Paul for giving us the opportunity to present today amongst this stellar lineup of presenters. What a bunch of legends and what a powerful topic. Thank you to all out there watching and taking the time out of your busy schedules. I'd like to acknowledge the traditional owners of the land and all First Peoples, past and present. Very excited and grateful to be here to tell you about what we at Crafted Hardwoods are up to. Just going to share my screen now so you can see the presentation that we're going to do. Yeah. All right, great. So, Crafted Hardwoods was founded in 2023 with one simple but ambitious goal: producing a timber that could address the current supply challenges whilst also be deeply rooted in sustainability. We transform sustainably sourced low-value pulp-grade wood resources that Daniel and the guys were mentioning a lot into premium hardwoods with the look, feel, and properties of century-old trees in one day right here in Australia. We want to not only provide the industry and market with an environmentally conscious building material, but to use innovation as a vehicle to contribute to our community's health and well-being and support those that need a helping hand. Painting a bit of a picture here with the speakers before me, I think we all sort of can feel there's a problem we're facing, and I think that's to say there's just not enough hardwood for the construction industry moving forward. Hardwood trees, generally speaking, have a very slow natural growing process. We're seeing the increase in government legislation to protect native forests. In addition, traditional sawmilling technology, through, I suppose, no fault of their own, has a yield of 33%. And the World Bank forecasts that global timber demand will quadruple by 2050. So using the current approach, there's no way this demand can be met, we feel. Excited to say that Crafted Hardwoods has a solution. We're using an Australian world-first innovation to produce a material that we feel truly can make a difference using an advanced technology, and it's made right here in Australia, for Australia, I suppose, and New Zealand. I think there's a few Kiwis on the call. Shout out to you if you're interested. We're bringing the market timber like nothing else on the market. Through science and engineering, we're turning pulp-grade resources into a beautiful, safe, durable, and sustainable product from regrowth forest and plantations for both soft and hardwood, using our unique patented technology to create timber products with properties that rival century-old trees in just one day. Our timbers offer an unprecedented solution to the increasing demand for low carbon, toxin-free and renewable building materials. It's touching on some of the resources that we do have. On average, 1.7 billion cubic meters of trees are logged globally every year. Of that, only 7% is processed into sawn hardwood. 17% is processed into sawn hardwood. And then we have 30%, being 32%, that is processed into high quality veneer products. And the rest is 44%. It's classified as pulp logs and will most often go into low value products like wood chips and exported to other countries if it's from Australia. In Australia, our number is actually a bit higher at 49%. So to understand those numbers closer to home, in 2022, we here in Australia exported 4.6 million tonnes of hardwood chips alone. Through our process, that's the equivalent of 4.5 million cubic meters of timber. So we feel we have the means to turn these resources into solid hardwood timber and make a difference to the upcoming or even current supply shortages. So our process starts with low value pulp logs. These logs get rotary peeled into veneers using as much of the tree as possible. In fact, via this process, we can yield 75% of those logs compared to the traditional sawmill methods that have that around 33%. This process at the moment, we're relying on the foresters, our suppliers directly at the mill. Our ideal resources, linking into what Patrick was saying, and even Mark, our ideal resources are 12 to 20 years old. And to answer one of the questions in the Q&A, we only source material that is FSC or PFC certified. Technology was created by 3RT Australia in partnership with Flinders Universities, Henkel and Bosch. At its heart, our process uses a water-based non-toxic nanoglue that biomimics the natural lignin found in trees. This allows us to give juvenile wood the remarkable properties of mature trees in minutes using robotics and artificial intelligence. We then press the veneers into large timber billets. Our process is quite efficient. A single machine can produce about 300 kilos of timber every 15 minutes when it's up and running and at its potential. Our square billets to saw material has minimal wastage. The challenge at the moment is our press length, which is 2500, but we can overcome longer length requirements with standard machining such as finger joining and laminating, increasing the applications we can be used for. We offer a range of both domestic and international species, which we get asked that a lot. Our process, we feel, still is a positive solution for imported species because we're still upcycling that pulp log resource into high value products here in the country. And as part of our growth over time, we'll continually add more species and add more to that, hopefully more from the Australian native species. Sort of rush through that a little bit, but just to summarize the presentation side of things, we're extremely proud as a business to be pioneering a way of producing timber that's not only maximizes the utilization of our forest resources, but also upvalues our most abundant wood resource of pulpwood. We can help fulfill the demand on the topic of MECLA, low carbon, toxin-free building materials by providing an additional supply of appearance-grade hardwood for both indoor and outdoor applications. We offer reliability in our supply chains whilst having a positive impact on our climate emergency. So that's just a bit of a run through on what we do. So I'm going to close the slideshow now, and just there's one couple of things I wanted to add just on the back of that presentation. More about where we're at in Australia. We're always investigating alternative supply chains internationally to add choice to current and future customers. But Australia is challenging due to very few businesses having the right setup to suit our processes, such as a rotary peeler and veneer drying equipment. At the moment, we rely on the forester to perform those things, which is awesome for quality control and certification, amongst other things. But it does make supply difficult for Australian species. It means that we can supply PFC material in Australia, but not FSC, and it does mainly come from regrowth. The best use of our technology is reflected in our white gum, which is actually from Brazil, the majority of which is approximately 12-year-old juvenile pulp logs that are from plantation forest and 100% FSC certified. I think the closer that we can get to that in the future, certainly would be better, and potentially we might need some help to do that if we're to do it in Australia. So I suppose I've been thinking a lot about what does that look like to do that in Australia, and are there interested parties out there to help make that happen? There's a few scenarios where I can think which are very limited on my thinking, but I'm sure some people correct me if it's offline. It could be a forestry business that wants to do more with their resource and get into veneering to recover more from their logs and are willing to invest in the equipment and associated expenses to do so. It could be agroforestry. Is there someone out there willing to set up a facility with other services that could be a central point to service a wider agroforestry community? How good would it be to get some of Mark's spotted gum logs from down there in Geelong and turn it into some engineered timber? Or what's probably most likely is that we as a business raise funds and set up our own facility, potentially with other interested parties, which seems to what have happened in other areas. A lot of businesses have the right machinery, but it's for their own operation. It's not for the wider industry, like finger joining, for example. And we might very well do that, but it certainly will take more time and potentially years for us to have a larger impact to benefit the Australian forestry industry to our full potential. So they're all, I suppose, very service level questions, and I'm sure there are plenty of challenges with everyone as to why and why not. But if and when we can gain access to more Australian resource, we feel we certainly can make a bigger difference. Just from our limited experience, Australia does seem very risk averse, perhaps for good reason. But if we're to make a bigger difference in a climate emergency, perhaps we need to be a bit more bold in how we go about it. So yeah, first things first, we need to increase our volumes to be able to invest further and have a larger, more positive impact on our industry. So everyone listening, if what I've presented interests you in any way, please reach out. Thank you.
Thank you, Darren. Hopefully that stimulates lots of conversation and follow-on feedback for you. Please stay on the line. We have Paul Ha coming up now. There are lots of questions in the Q&A. Many have been answered already, but yeah, please keep them coming. It's going to be fun to juggle our way through those in the panel discussion. But Darren, stay on the line. That was fascinating. Look forward to speaking with you shortly. In the meantime, Paul Ha, thank you for playing such a role in pulling this group together. I'm looking forward to your presentation. Over to you, please.
Yeah, thanks, Hudson. I think Darren might need to
stop sharing your screen.
For me to.
All right, that's gone. Great.
Great. All good. I think we're good with that. Yeah. Okay, so I'm going to share. Okay. Oop, close. Okay, yeah, thank you. Look, I'd like to acknowledge the First Nations people of the country I'm on here in South Gippsland as well, and they're the Bunurong and Bunwarang people. I'll start with these words from Patrick, and that is that we all like forests and we all like wood, and therein lies the rub. So native forest logging that's focused on wood production has now ended in Victoria and Western Australia, and my guess is that other states will follow in due course. Until the forest wars end and our politicians find the courage to respond to the science that Patrick has shared with us, and our First Nations fire stick farmers have practiced for eons before, where's our wood going to come from? In Australia, we've got lots of plantations of exotic softwoods like radiata, slash, maritime pine, but not enough to meet the rising demand. On the whole, our state governments and corporations are showing little appetite for establishing more exotic softwood or native hardwood plantations to grow construction timber. Check out the forecast for plantation hardwood sawlog supply. So that's the orange band, if you can see it, in my part of the world that can grow trees really well. The timber plantations we do have are mostly monocultural and they lack biodiversity, but that doesn't need to be. They can also be of multiple timber and non-timber species that better support biodiversity and still yield good volumes of straight sawlog timber within 25 to 35 years. This afternoon, we've learnt from Patrick and Mark that we can use smart silviculture to stimulate fast return of the carbon stock that's removed from a plantation or a naturally regenerating forest. And that's because it affords improved onward growth for the trees that are retained. And it can also provide biodiversity benefits for better resilience for hotter and drier summers that we've got ahead. So much of the wood fibre that's harvested through climate active and forest health centred silviculture, that's not well suited to big sawn wood production. That's been our default for so long now. But this non-millable wood, it can be engineered into long-lived building product, as Daniel and Darren have shown us. A healthy proportion of the above ground carbon stock removed at harvest from our fast-grown pine plantations, it is converted into long-lived building product. This conversion, it's higher where the thinnings and the non-millable tree tops from harvest are processed into engineered wood products, or EWPs, like particle board and fibreboard. Now, clear-cut harvesting of our native hardwood production forests, which for the most are not managed, that sees much less of the carbon in extracted biomass converted into long-lived building product. And the deeper forest carbon debt incurred by that harvest is repaid more slowly in the congested growth that returns, which is what Patrick showed us slides of. It's unfortunate that the environmental product declarations we work off, that it used to inform our material choices and our buildings life cycle assessments, they don't embrace this critical, potent and greatly varying forest carbon debt, which is attached to differing production forestry methods. And the figures for global warming potential of biogenic building materials are not weighted to reflect the little time we've got left for impactful carbon drawdown through forest regrowth in an increasingly hostile climate. And this was explained in more detail in a presentation I gave to MECLA Working Group 5F last year. Our rising appetite for hardwood in architecture, combined with our fading local access to it, mean that we now have lots imported, as Daniel and Darren have pointed out. And comically, an increasing amount of it is of species indigenous to Australia, but they've been planted in countries like Brazil, Chile, Uruguay, Vietnam, India, South Africa. There's a significant carbon footprint also attached to shipping timber across the planet. and we've got little way of knowing what pre-existing ecological or social values these offshore plantations have displaced. But located in warm or temperate climates with good soils and good rainfall, they also sequester carbon from the atmosphere at really a great pace. As Darren noted, engineering with rotary peeled veneers from juvenile forest thinnings, that sees a greater proportion of the harvest processed into timber product and long-lived carbon in buildings. In addition to glue laminated timber and cross-laminated timber, CLT, mass timber can also be a layup of multiple billets of laminated veneer lumber, or LVL, and sheets of plywood, and they call that construction mass ply. Provided those veneers that make up these EWPs truly are from locally fast-grown wood, that then also affects a fast payback of the potent carbon debt incurred at the cradle by the forest harvest. Now, it's easy to get a rough handle on how well or how quickly wood has sequestered carbon dioxide from the atmosphere. So just simply grab a lump or two, check if it's heavy like red gum or if it's light like pine, and know that the carbon stored in dry wood is always directly proportional to its density. And most importantly, look at the end grain, because every growth ring represents a year in the life of a tree. So the individual backsawn sections of Daniel's GLT from Tasmanian grown plantation shining gum show around 5 to 7 years of growth, and that's CO2 sequestered really fast. The same sized backsawn sections of similarly dense native forest mountain ash or Tassie oak in GLT on the rack at Bunnings shows around 15 to 20 years of growth. So that's a much slower sequestration. And what's the story with Baltic pine and spruce that are now imported in vast volumes from cold boreal forests of Russia, Europe, Scandinavia, and the Baltic states? Over the past decade, they've certainly been the dominant scantling wood on Bunnings racks in Victoria. Rift-sawn sections of Victorian-grown radiata pine on the left, they show around 8 to 12 years of growth. The same sized rift-sawn sections of Russian-grown Baltic pine on the right show around 70 to 80 years of growth. That's a big difference. And again, their densities, these two woods, are much the same. If they're harvested in Western Europe or Scandinavia, Baltic pine and spruce are probably from historically replanted forest. If they're harvested in Russia or the Baltic states, they're more likely to be from intact, unmanaged natural forest. So whether legally or illegally sourced, it's really hard for us here to know what we're getting. It's also hard to get a handle on the carbon story behind rotary peeled veneer products like LVL or plywood that are available in Australia. But I can say that if your LVL is supplied with a blue paint coating, it's been manufactured in WA from locally fast-grown radiata or maritime pine. If it's not blue, as most of it isn't, it'll likely be from very slow-grown trees in those cold boreal forests. Most CLT and LVL, and much of the GLT that finds its way into big construction in Australia also draws on spruce and Baltic pine from these forests that take from 80 to over 250 years to return to anything like their pre-harvest state as holdings of carbon and biodiversity. For Australia, in this emergency, such wood is not a climate-friendly building material. So cutting to the chase, I reckon we need many more marks. So farmers who plant comparatively fire-safe agroforestry patchworks across our vast treeless hills and plains. For some decades now, Australian forest and timber industry, it's been concentrated into fewer and bigger public and private business concerns. But there's also, I reckon, a strong environmental and social case for local community-based co-ops that can support farm foresters with education in silviculture and access to improved seedlings, with roaming contractors with equipment for planting, pruning, thinning and felling, with on-farm milling, machining and drying, and with on-wood product distribution and retailing. So with some nimble gear and some smart support at hand, I'm regularly impressed with how well small local enterprise with trees and wood can stack up. And if you multiply that model 1,000 times across Australia, you've got substantial collective forest and timber industry. As a not-for-profit business arm of Ceres Community Environment Park in Melbourne, Ceres Fair Wood connects local tree farmers and sawmillers directly to an environmentally and socially conscious market in Melbourne. And that's a demographic that really values the wood it has on offer. Fair Wood acts as aggregator, fair trader and educator. Just one of the many timber products on offer at Fair Wood is this blue gum, which was planted in 1992 by beef farmers Frank and Sharon Hurst right here in God's country, South Gippsland. It was form pruned and high pruned through its first roughly 10 years of growth, and it's been felled by Frank over the last 5 years or so. The logs were trucked, milled and machined into shiplap wall cladding by sawyer Dan Bright, who's down the road at Fish Creek, and then it was fixed into a wall at Mark's home in Melbourne late last year. Don't let people tell you that high-quality Australian hardwood species can't be grown at pace in plantation. Roughly 870 kilograms per cubic metre of air-dried density, and lots of atmospheric carbon sequestered in under 30 years on what would otherwise have remained a steep cow paddock. Wood product engineering, it can also succeed in this small local scale. So Radial Timber at Yarram in Victoria, it's currently trialling manufacture of a shiplap wall cladding. That's a 6-ply lamination of rotary peel thinnings, and they're sourced from its own nearby hardwood plantations that aren't yet mature for sawlog harvest. And I can see small robots like those that Darren has shown us dotted across the countryside, processing local peelings from existing low-value pulpwood plantations into high-value, long-lived architectural product. And a return to Australia of machines that crush and bond juvenile wood fibre to scrimba. Our CSIRO invented scrimba in the 1980s and then sold the intellectual property to America for commercialisation and then export back here to Australia as parallel strand lumber. This afternoon, we've spoken a lot about holding on to carbon at the cradle, so in the forest. There's also discourse on carbon at the grave, when timber products come to the end of their service life in buildings, and how wood in landfill also affords long-term carbon storage. Now, sending waste wood to landfill, that's still common in Australia, but it won't be, say, 10 to 200 years from now, when the wood we put into our builds today is finally decommissioned. Landfill is simply becoming too expensive. And without access to elusive carbon capture and storage technology, incinerating waste wood for anything other than biochar is not smart in this emergency. But repurposing waste wood from a prior to a new construction use, that's always an excellent option, whether in its original form or reprocessed into an engineered product. At Benalla in Victoria, D&R Henderson makes particle board from 100% post-consumer wood waste. Through its urban forestry service, Ceres Fair Wood teams up with arborists from Victorian, state and local government to salvage wood from trees that have fallen in the wind, died standing or need removing for major road or level crossing removal projects. Rescued from mulching in a chipper that'd have wood fibre decomposing to carbon dioxide in quick time, Fairwood converts this resource into long-lived timber for its own retail stock and for return to the site where it grew as a hard landscape element built by Fairwood's carpentry team. Whilst this is a job from a while back, it's an earth-covered library and wildfire shelter in Victoria's Macedon Ranges, and it reflects some principles of climate-active timber selection and design. It's got a roof structure of LVL, sourced in WA from fast-grown plantation maritime pine, that's solely screw laminated for easy disassembly and reuse down the track. It's got ceilings of plywood that are sourced from fast-grown hoop pine plantations in Queensland, and door, window and interior joinery from blackbutt, that's out of an old Sydney warehouse, or from macrocarpa, that's salvaged locally from dying farm windbreaks. Most construction timber, with its stored carbon, it ends up in low-rise housing. Mullum Creek is an eco-housing estate in Donvale, Victoria, which has steered 56 lot owners, many architects, engineers, building and landscape contractors to select timber products in accordance with really strict environmental criteria that are informed very much by the objective of preserving forest carbon. This requirement was set by design guidelines, and it was tied to the purchase of lots and was tightly controlled during construction. But it was also backed up by a comprehensive list of environmentally responsible and affordable timber choices for all applications. And this regularly updated list, an explanation to what informed it, and other Mullum Creek timber info sheets, they're freely available on the web. So, vertically integrated enterprise with trees and wood, it can be environmentally, socially, and economically regenerative at both large and small scale. I reckon it's time to press the reset button on how we work with trees and wood as foresters, timber processors, architects, engineers, builders, and policy makers. And we need to work together also very much with our First Nations people, because then we can make the best of this new world that we're now in. So thank you, everybody.
Paul, thank you very much. The MECLA community is a very practical group, and so seeing examples of organisations that are doing what you are proposing is great, and then seeing projects that have applied the use of, I suppose, alternatively sourced timbers is also really helpful, because it's not just a theoretical suggestion, it's a, hey, here's the idea, here's the application, and this is what it looks like. So very interesting. I'm going to ask all of our panelists to come back and turn their cameras on now. Also making the call that we're going to run over time. This is being recorded, so if any of our audience have to duck off to pick up kids or do whatever they need to do in the office, you won't miss out. The recording will be shared to all attendees, but with this wealth of knowledge in our speakers, it's probably inevitable that we've gone over a little bit. So apologies, but let's adapt. Let's go on. If you gentlemen are all happy to keep talking for a bit. So Patrick, Mark, Daniel, Darren, and Paul, thank you. I think you've put a lot out there, but backed it up with examples, whether that's, time-lapse photographs for you, Mark, showing quite how agriculture and forestry fit together, but not just fit together, that they both benefit. I think that's a real takeaway. And then for the suppliers, Daniel and Darren, to have, examples of how your processes, how your manufacturing and investment up the chain results in an alternative product, it is encouraging, because Paul, you're saying hit the reset button. Recognizing that MECLA people are practical, a couple of the questions have been around cost. How does business as usual compare to the alternatives of I suppose, a manufactured hardwood product? How do they compete? Maybe Daniel and then Darren as as producers.
I like that question, and I'll talk about it in the mass timber context. How do we compete? You do need to get the most out of every stick or every log that comes to you, first of all. If you don't have a home for everything, then your costs get allocated to what you are selling pretty quickly, and that blows out. So that's the first thing, is getting that right and having a market for everything. That's responsible, but that's also sustainable. In the mass timber context, that we're asking people to, right now we're riding a bit of a wave where there's people are taking a risk, and they're building something that is appealing to a client who's more sustainable or wants a better occupant outcome. So we're riding on a bit of a wave there where they're prepared to take that risk. But one of the big issues we've got right now as an industry is it's very hard for cost assessors or builders who are new to it, or installers, to understand how to price this thing. So quite often what they do is they apply their traditional knowledge and then plus some contingency in various forms. It's understandable. So what we're trying to do is ask people, get us involved in our competitors, other people in the space, as early as possible, design for efficiencies, and understand where the cost efficiencies are. So I touched on briefly, a mass timber building designed well should install 30% quicker. Now you need to factor that into your costs, because the column itself could actually be more expensive than the concrete column. So there's a different way of doing it. If you're really keen on doing it and you want to do it more cost efficiently, I think you need to partner up with the right people and satisfy yourself.
Okay, so whole of project cost, not just item ticket cost, is going to be important. Darren, do you have a response as well?
I've got a twofold response. You could be talking about price now, or you could be talking price 5 to 10 years down the track. If we don't have the right resource, I do fear that we could be at the mercy of international markets if we don't have enough of our own resource. And I think we learned that through COVID a lot. So like if that combination of what Daniel was mentioning earlier about closing up native forestry, which I think we all support as long as it's done in the right manner. And I think the statistics around plantations, which might have been in the Q&A, that's not promising at the moment. From what I understand, we are pulling out more plantation that we're planting, and I think that could certainly be a concern. And what the price is now for Australian products, once it demand outstrips supply, watch the price increase a hell of a lot. So that's just something to consider. For us, like our goal, we're so early in our journey compared to someone like Ash. So like our biggest concern is people's acceptance of our material. So we're trying to remove all resistance we can from them selecting it. So for us, we want to be as close to traditional material as we can be, or conventional material. So that's what our goal is. We get pushed to do a lot of conventional products, but we're also trying to yield the best solutions out of our unique block size. So we produce a block that's 500 by 250 by 2.5. If you'd use it for a stair tread, for example, a 70mm stair tread, you laminate 8 pieces or 7 pieces of timber together. We can get quite a lot of efficiency in that situation because we've already done the laminating in our production process. It is easy to supply, therefore it is more cost effective in that situation. So that's just an example of some situations lengths and issue size better than others.
All right, good to know. Very practical answer. One of the roles of MECLA is to stimulate demand. We have a demand side working group all about stimulating the demand for low emission alternatives, for better thinking, for better products. What role, and so someone unfortunately anonymously has asked, what role can the property sector, the development sector play in stimulating demand for engineered wood products, and what could government do? Maybe Patrick and Paul, if I could ask you guys your perspective on that.
I'm going to default to Paul on this one because I'm just involved in how do trees grow. The building sector is something a bit more naive to.
Fair response, Paul.
Yeah. Okay. Look, I think you touched on it there, or the person who wrote the question around if developers. I think it's great if they can certainly work and team up with government and explain, with regard to engineered wood products, particularly the kinds that we've talked about this afternoon, these ones that really can hold, that can be drawn from forests in a way that the forest can still remain resilient to the changing climate and remain a carbon stock. If those kind of products can not only be valued by developers, but valued by the public more generally through our governments, our state and federal governments, because of the benefits that they bring that go beyond just the value of the column or the beam as it compares to a concrete or a steel column. I think that's where you start looking at value in ways that just go beyond the quantity surveyor's kind of figure in terms of price.
Okay. Now, Mark, can I turn to you? What you've put forward shows increased farming yield, better lambing results, improved soil carbon, reduced salinity, reduced erosion, and you've got a timber product growing as well as another income stream. Why isn't everybody doing this?
Oh, it's a good question. And again, referring back to Rod Pennon, we've done a lot of work on looking at barriers, and I know some of the people participating in the audience today will have looked at this as well. There's a context on this, is that we're good at certain things, farmers, but we're not good at everything. And I think so there's a knowledge gap. I mean, we're at Hamilton, where we're at, when we first came here, there were 6 foresters employed at the local government authority. There's none there now for the last few years. There's no one training in that space. So there is a knowledge gap. So the only people who come forward to us are the actual purchasers of products or the commercial ones. And that makes you quite nervous. You don't know whether what they're suggesting is going to be there real. You're making a 25 to 30 year commitment. You don't know if the genetics are the right ones. I know we've got the genetics wrong in some of our trees. We went for wild stock. We didn't realise that there were certain cultivars that worked very well in frost-affected areas. And, if we did it again, we'd do it quite differently. Then you've got the expertise issue about how do you thin and who's going to do the thinning. And so this is where I think to sort of cut it short, I think you need to have really meaningful partnerships. So, I mean, one of the beauties for farmers is that most farms I know, I've looked at it pretty carefully, with the exception of some high value irrigation country and some of the dairy stuff bits further south, they can have about 10%, which is unproductive land for a variety of reasons, which suit certain trees. So that to me is where you target the species that work in that area that you're not getting your value at. Now, if you did that, then you need really good advice and you need to have partners going forward. The other one is that, just putting all that to one side, is shelter belts work really well. So what we need the persons, the people who come and purchase the product or get the contractors to come and do it. They have to work in these smaller situations, which a lot of them don't want to do. They're used to having, mass. And I think Patrick's example at the beginning, where they did that selective logging example, is a really good one, where we could do that going forward. But I think it's an interesting one. But the other one, to be slightly negative, we bought our country here between $400 and $600 an acre. It's now worth $8,000 to $10,000 an acre. So for a farmer to make that commitment and look at a 25 to 35 year rotation return, you need to have other factors in there that give you the return, and perhaps a lease agreement. So this is where I'm at now, is I think farmers look at someone else owning the trees, taking care of the trees, selecting the trees, growing the trees, and paying a lease payment every year for that 10% of that country. But you need patient investors for that. And I'm not sure if the industry is mature enough.
Right. So
it's a long answer, but there's a lot in it to unpack. Else people would be doing it.
Yeah, it's obviously very complex and needs patient capital. So I guess that answers the question why everybody isn't doing it, because it's hard.
Yeah, although to be more positive, I think timber companies are realising there is a shortage coming forward, and probably some of the best people going forward, I think, in terms of patient capital in Australia, are superannuation funds.
Mm.
I mean, they have got long-term horizons, and they want to seem to be doing ethical investments. So there is some. This is bigger than Mark Whitten sitting on his farm in Western Victoria.
Yeah.
But I think there is some options there where we need to. Perhaps the next conversation you have to do is with some of the financiers.
Well, I'm wearing a MECLA hat talking to the investor group on climate change next week, so I will carry this conversation forward with that suggestion, Mark. Patrick, let me bring you into the conversation. You quickly said you're on the growing end of things. Now, each of us, there are 6 white fellas on this call, and each of us recognised that we're on Indigenous land. It's been said that this has to be done with traditional owners. What does that look like? What role is there? What cultural lessons can we learn? What does that engagement, and practically, what does it look like, Patrick?
Well, so I won't presume to speak for the traditional owners and how they view this. We're working with various traditional owner groups in Victoria, Tiwi Islands, and beginning to have some conversations in Western Australia. I think the big challenge, particularly in the temperate, so the southern forests, where the traditional owners were pushed off the land earlier and perhaps more aggressively, is that the forests have been heavily impacted by land use change, whether that's agriculture or land clearance or logging and so on. And in many parts of these landscapes, the forests that have regrown or have developed just have no sort of cultural connection, or there isn't any cultural connection. The composition or the structure is quite different. And so where we're at is really at the beginning of having conversations about how is it that you envision your forests in, going forward in the long term. And from it doesn't matter if it's traditional owner question or if it's just a straight up timber production, the fundamental pieces of the puzzle are you need to know where you're going to try and get to, and you have to know where you are, and then we can look to see, what are the various pathways to get there. And I think certainly here in Victoria, there's a lot of interest in trying to reintroduce cultural burning into forests. But if you have very dense forests with lots of small trees, it doesn't take a very hot fire to kill a lot of the trees because the small trees are sensitive to the fire. So thinning combined with low intensity fires is, one step towards shifting to more open forests where cultural burning can be a more common practice and effectively a safer practice. However, as I said, different cultural traditional owner groups have different views, have sort of different comfort levels with how they want to engage in this. And so it's very much a sort of conversation and process that, we're sort of trying to work with them on that. And there's also this sort of notion of sort of two worlds walking in parallel. So taking the traditional owners' knowledge and then the Western science. So for example, I know a lot about how many trees, per hectare you can have of this species on this kind of site. Whereas, for the traditional owners, they may have more of us, more interested in some of the understory plants, and we're interested in seeing how those two things may relate to each other. And so I think a lot of it is this sort of iterative exploration of the space. But that really takes time, number one, and it takes trying different things. And I think this is one of the things that, we talk about the traditional owners as the first scientists. This is what they did. They tried something, they watched to see what happened. If it didn't work, they'd, try other things. And I think, we're moving into a different climate, we're living in a different world. We've got different objectives, more objectives that we want to get out of the forests. And I think we're in a place where we really need to start trying more things to see what sticks and what doesn't, and then use that knowledge to sort of move forward. And then the one last thing I would say is, in many ways, I think historically we've looked to governments to give us guidance about long-term management because the government's always going to be there. But with politics being politics, we have quite a lot of variability in the policies from one government to the next. someone, I think Mark brought up the superannuation groups as sort of long-term investors. I mean, ultimately, the traditional owners are the long-term custodians. They're the ones with the real long view of what they want their country to look like. And so engaging with the traditional owners to talk through that and think through how you get to where they want to get to, I think is a really fundamental part of this entire process. Doesn't matter where along this wood supply chain you are. I think going forward, it's going to be the foundation of it.
Terrific. Thank you, Patrick. Now you finished by saying along the chain. A couple of the questions have been about end of life. What happens to these timbers now? One of MECLA's founding principles is moving towards a circular economy. So hopefully we're not seeing, buildings demolished and off to landfill and new virgin materials into the next building. But what does end of life look like for engineered wood products? Maybe Paul, and then maybe either Daniel or Darren.
Yeah. So I think these engineered wood products, if they can find their way to reuse as long-lived building products in either in some other form, reprocessed, or just as they are. I showed an example of a building where if they're, for example, mechanically or just screw laminated together big LVLs or sections, you can then disassemble those after the use and reuse them in probably a whole range of ways. But the trick is to try to avoid, I think, putting it into landfill, because in landfill that's not circular economy. That's just an end waste. Yeah, and so long-lived building product, ideally not chopping it up and burning it and saying that's a bioenergy, because so that's we're creating heat energy or electricity from a renewable resource, being wood, because we're in an emergency. We've got the next 25 years are the years we're going to be able to be really impactful in terms of drawing down carbon. After that, it's going to be really difficult. If we burn, which is what people also talk about, and they say that's circular, it's not, because burning waste wood, you have a much higher emissions scenario based with that if you haven't got carbon capture and storage per unit of energy you're generating, or electricity, or whatever it might be, or heat energy, than you would if you burnt dirty brown coal. So that's really not an option for us. And I know there's been some points made in the chat around biochar, and they're really interesting. It's a really interesting thing. And I was just speaking with Chris McAvoy, who runs Radial Timber in Yarram yesterday, and they're really moving along in a wonderful way with the wood product, the wood fibre that they bring into their place at Yarram, and just processing that to get really high recovery from a log into long-lived building product. And then the waste that they do have, they're doing marvelous things with putting that actually converting that into biochar. And yes, you do, when you create that, there's a heat output from that. They're using that heat from the biochar production. They're using that for drying the peeler logs that they then are making these laminated products from. They're generating electricity that they use for their own mill, and they can actually export to the national grid. So they're really, and there's very little, from what I understand from Chris, very little carbon emissions at all from that process of creating that biochar. Now, it's not an area I'm particularly, smart on, and there are other people here, and I noticed someone in the chat might have even been from a company that works on biochar plant and that sort of thing. So that's a really interesting area as well. But as a first step, try to put it right back into long-lived building product, and design your buildings in the first place to make that a possibility. Yes,
one of our members built launched a disassembly, how to write a disassembly guide, as a contribution to this whole conversation of circularity, to say, as well as, okay, what are the instructions for how do you build the building? What are the instructions for the reverse? so that it's not just demolished, it's disassembly and disassembled and can be reused. Look, I've just seen the time and I said we'd go 10 minutes over. We've done that. What I'd like to do, and you're all so knowledgeable in this field, but if you could just say one takeaway for our audience. The Q&A has been very thorough, and I'd encourage you to answer some questions that may still be there if you have the time. This will be recorded and shared. It's been so rich with information, but Mark, what's a takeaway for this predominantly city audience, I'd say? What do we need to know? What's your final comment?
Well, it's in some ways it was stealing from Patrick's idea at the beginning, is that forestry is a really, it's, I think I copied it, changed it slightly, but forests can make the focus, should be the focus on farms, for the sole reason that it's a part of integration, and in our context, it's a very important part of the jigsaw piece that we've got. The co-benefits are immense. If we look at any one reason why we do timber, they don't stack up. If we look at all the combined reasons we do timber, that's the take home.
Great. All right. Nuance and complexity. I think that's what MECLA's all about. So that resonates. Patrick, to you.
Right. So I would make the point that I made in my talk, I think, and that is forest management ultimately is something we're going to do, and we can use it to advantage, and particularly where we can link the forest management to make forests more resilient to climate. In large part, that is store more carbon in the forests and use that as a tool to put more carbon into buildings through wood and wood products as opposed to steel and concrete. That's win-win, but it will, as Paul said, I think, take a real reset about how we think about the whole system, from the growing to the processing to the building. And I think that's, there's some important discussions that we need to have as, across both the public and private sectors.
Okay, well, this is part of that conversation. So Patrick, thank you. Darren, your closing remark.
I suppose I just encourage people to be open and willing, and have a bit of a tenacious appetite to learn more about how they can make a difference when designing. I suppose that's the part of the industry that we're involved in. So yeah, it's a level of willingness to accept the features of timber if you're looking to use it as a aid in reducing your carbon footprint.
Thank you, Darren. Daniel, your final thoughts.
I'd probably loop back to circularity in timber. Obviously, there's the normal hierarchy we should follow: use less, don't build at all, reuse. We certainly see those opportunities, particularly in mass timber. But I think timber's circularity is different to other materials, and we should acknowledge that providing, when we're using timber responsibly, if we use it for long-lived products and then we're growing at end of life, we're going to see carbon build up over time, providing the average use of that wood fibre is out there longer than what the forests are.
Okay, that's great. Thank you, Daniel. And Paul, thank you for bringing us all together. This has been, your response to the earlier session or the session late last year. What would you leave us with?
Yeah, look, I think the take homes from the other speakers were just perfect, and it's hard to kind of put more to it, but I just reflecting, for me, it's been, as an architect, because we sort of at the end of the, architects and engineers and builders, we're at the sort of end of the chain in terms of these materials that are procured for the projects we work on. And I've just found so much pleasure and learning, and just work and life makes a whole lot more sense to me when I'm able to engage with people like the wonderful foresters and forest scientists I have, like Patrick, through the Gippsland Forest Dialogue and other kind of arrangements we've had. It's been really great for me to learn that, and then to be able to talk really, and of course I've known Mark for many years, and to understand this amazing way that we can work with, on farms, growing timber and growing sheep and growing meat and all sorts of other, and wool together, how those things, the co-benefits that come with that, that it's a win-win. And I've been able to spend time having great chats, and with Daniel, he's shown me around ash And I've learnt so much from that sort of stuff. And I'll just encourage other people from my kind of disciplines, from the design disciplines, to kind of do that as much as they can, because it makes what we do much, much richer. I think both by design, but just the process and the joy of it, I think. So thank you.
Wonderful. Well, gentlemen, thank you all very much for your candor, your expertise. The level of stimulation and the number of people who've stayed on the call for this little extra encore component really demonstrates that there's a real interest. I think MECLA has a role to play in furthering the demand for engineered wood products. So thank you for what you've done today. I'd also like to thank Alexi Barnstone and Kati Verheyen from Climate Kick. Behind the scenes have pulled this together and make it happen. As always, I give my thanks to Monica Richter from WWF. She's away on holidays at the moment, but nonetheless needs a shout out because she does so much work for MECLA. Thank you to our audience for dialing in today. There will be a recording, and we'll synthesize the Q&A as well. A lot of follow-on links for those who really want to dive in, and several other comments saying, yeah, I'm going to share this with my sustainability team or my colleagues. So the ripple effect will continue. Please, for those in the Engineered Timber Working Group, carry on. The Do Tank has a lot to do, but today is a great window into what the conversation looks like and what the positives can be, as well as the challenges. Thank you, everybody, for today. That's it for now. Just keep an eye on MECLA socials and our newsletter for what happens next. But for now, that's all. Thank you very much.
Thank you, Hudson.
Thanks, everyone.
Thank you.